Now let's have a look at the sketch. Here's a sketch for the example, and what I've got here is just a few different waveforms. This first one here is very simple. It will just raise the voltage on the output pin from 0 volts, which corresponds to value 0, to 3.3 volts, or approximately that, which corresponds to value 255, and we'll use the DAC write function for that. So in the DAC write function, we need to provide the GPIO which we want to use, and it's either going to be 25 or 26, and then the 8-bit value from 0 to 255. So in the first for loop, I'm producing a raising slope from 0 volts to 3.3 volts, and in the second loop the voltage drops. So from 255 or 3.3 volts approximately, it will go down to 0. And again, I'm using DAC write to produce that in the output signal. And then I'm going to show you some other examples of sine wave signal and a square signal and a triangular signal, which is actually calculated on the fly using a little bit of trigonometry. So if you are familiar with trigonometric functions, and this is going to make sense. But we'll see what the outcome is anyway. So all you've got to remember to do is you can generate any kind of waveform or any kind of voltage output in the DAC channels by either writing a value directly in DAC write or creating a formula that will generate the function. If you have studied my other course, Advanced Arduino Boards and Tools, I've got a lecture here that shows you how you can actually use calculators that can generate arbitrary waveforms that you can store in an array and then produce and call and write to the digital analog converter. So if you are interested in learning more about this topic, have a look at this lecture.